We're going to see one similarity and one difference between graph A and graph B. Similarity and difference. Okay, so what do they have in common? Jake? Okay. Yeah. Yeah. I think that one has 4. Oh, they both have 4. They
No,
both
one has 5.
but just a conversation. That's definitely one thing we could have looked for. Yep. Okay, they have the same slope. They have the same rise over run. We call that M, right? Or we can even call it K for the direct variation one. What is the slope? Yeah, you can say 2 over -1. -2 over 1. They both go down 2 over 1, down 2 over 1. So what is their difference? What's happening on the y-axis is different. What's it called? The whole line's the y-axis. What's the... Y-intercept is different. They have different y-intercepts. This y-intercept's at 0, and this y-intercept's where? The other 1, 2, 3. It's at 3, yeah. So their difference is that they have different y-intercepts. I guess they also have different x-intercepts. Different intercepts in general. Okay, so that's the main. You could have maybe said something else. I don't know. You guys are coming up with really creative answers. Guess I should have called this number 1 because I'm going to make it number 2 right now. All right, your next challenge is to write the equation for these graphs. Shucks. Yeah, now we need to make an equation for the graph. So graph A, I think you can do. I'm not sure if you can do graph B. I'm sure somebody can. So who can do graph A? It is direct variation. Graph A is direct variation, as Libby pointed out, because it goes through 0, 0. So our equation is going to look like y equals k times x. So I guess we just have to decide what we think k is. Who's got the equation for graph A? Let me just zoom in on it. If this is supposed to be written y equals k times x, what would the k value be? Logan? Yeah, -2 or -2 over 1. So we could just say -2x. So our direct variation graph is y equals -2x because we know that k value, or you could even call it m for slope, is -2. Now, how do we think graph B's equation is going to look different?
Y equals -2 over 1 plus 1.5.
Not 1.5. Good effort, though. It's not 1.5. There is going to be a number here. And you went with this value, didn't you?
Yeah.
It's the other one. It's the other intercept. Really close, Thomas.
Was yesterday a quiz or a test?
It was a test. So if if you have a direct variation, meaning you have a slope, but it doesn't go through 0, 0, you can't call it direct variation anymore. It's just a linear equation, and you'll have a number at the end. And the number at the end is the y-intercept. So if this goes through 3 instead of 0, 0, our equation is negative 2x plus 3. So let's just make a little note of that in this work. Put the y-intercept at the end. So these equations are almost exactly the same, but if your y-intercept is something other than 0, it shows up in your equation. Does anybody have questions about that? Yeah. What's the date? 28. 28. Okay, we don't have any homework or anything to go over, so we're just going to start some notes, which is pretty much what we're doing anyway, right? So let's continue this. I don't know, I have to change everything now. So I'm going to call this, just right under Bauer, call this notes. Chapter 4-1, we're doing awesome. We're already in chapter 4, right where we're supposed to be. Yeah. So in Bowork, I challenge you to observe differences and similarities in graphs, and now I'm actually giving you information about our new linear graphs that we're going to start working on today. So a line that is not direct variation can be written this way: y equals mx plus b. If it's not direct variation, we don't call the slope k, we call it m, just like you do in slope formula. And the b is the y-intercept. This is called slope-intercept form of a line. Okay, let's do a little fill in the blank. Quite a statement to write, but we're almost done. Slope-intercept form is just like, what do you think I'm going to say? I'm saying it already.
Slope form.
Direct variation. Y'all got all that wrong. It's funny, it's like you can't read my mind. Slope-intercept form is just like direct variation, except instead of starting at 0, 0, like direct variation, it begins at the b value on the equation, on the y-intercept. Slope-intercept form is everything that you know about direct variation, except it doesn't start at 0, 0. It begins at the b value on the y-intercept. So when you make your graph, you start at whatever number is there in the equation on the y-axis. I want to put y-axis there. And then you move your rise over run. Better. I'm going to write this down on the board, I guess. know social studies as well. All right, let's make a graph. Number 3 here is to actually graph slope-intercept point. It says label and graph it. I'll walk around and make sure. I love graphs. Lines. You got axes. Wish that came out a little straighter, but it is what it is. Did I let myself froze here? I did. I'm gonna do it out here. I can go back. Where you guys are making your X and Y.
-4? Why'd you go to 5 on all the other ones, but only -4 on that one?
My picture didn't go down far enough.
Oh, okay.
So this equation looks just like direct variation other than that -2 at the end. None of your direct variation equations had that -2 at the end. So to graph this, I'm looking at this model as if it looks like y equals mx plus b. So I'm going to begin my graph at the b value. Begin at the b value. So I'm going to start, it's a y-intercept. So here's my first point. It's not at 0, it's down at -2. Begin at b. Then, after you begin at b, you move the m value. So m is slope, and that's your movement, and that creates your graph. It's your rise over run. So our m value is 3/4, so we're going to rise 3 and run 4. Count up 3 over 4, up 3 over 4.
That story? Wait. Talk about that one that's like all the way out there, the up 3 over 4.
Let's check it. Maybe I messed up. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Yeah, sometimes I'm off by a line. You want to check it. Up 3 over 4. surprises. I think that's the last one. This is your last problem here, and then I'm gonna let you just hit your workbook. We're got some problems. It's not written up there yet. I think we'll finish it in class. So. Oh, there was a funny video I wanted to show. It's not that funny. It's actually it's like a parody that like some high school teacher did with his students. There's actually a bunch of them out there. It's just old. It's like I think it's like 8 or 10 years old. So it's not really. They just take a song and then they make it, about like math. So it's a song and then the whole song's about y equals mx plus b. I can put it on while you do your work. I'll put it on while you do your work. I mean, you might regret this. You might regret it. Are we done with the graph? All right, so our last skill, write an equation in graph. If you're just given these two pieces of information, you're given that the slope should be -1/2 and the y-intercept is 3. Write the equation and then create the graph. So if you're asked to write an equation, maybe I'll make this even more detailed. Write an equation in slope-intercept form. That's what this is called. Because it has a slope and a y-intercept. If you're asked to write an equation in slope-intercept form, your brain has to have this memorized, this form memorized. Maybe if you haven't written this out, this maybe should. Like, we have direct variation form. Well, this is slope-intercept form. This is just like direct variation, but it doesn't go to 0, 0. If it's not direct variation, they call it slope-intercept. Okay, so your brain reads slope-intercept form, and it has to think y equals mx plus b. So you put -1/2 in for m, keep the x, and then you put 3 in for b. That's the equation. And then you make a graph. This is really similar to the Bellward graph. A little too similar. What's the only difference?
It's positive.
The Bellward graph was? I don't know. Some of them have the M value.
No, the Bellward graph was negative.
This one's negative too.
Olivia, stop talking to me about this.
The Bellward graph was down 2/1, and this is down 1/2. The slope is reciprocal. Alright, so how do we graph this? Well, we're going to begin at B. On y-axis. So we're going to start right here. Start at the 3. And then you move M. And so M's usually rise over run. But since we have a -1, I like to call it fall over run. So I'm going to go down 1/2. Down 1/2. And I want to aim for creating that pattern to the left as well. There it is.
Now we get to watch the video. Oh, it's done.
Rise over left. But like, I'll never make the bottom negative.
Yeah.
Because I don't want to scenario. I'll just leave that negative.
I like the lessons.
Me too. You get pays, day after a test.
Yeah.
You need to overwhelm everybody.
Let's just watch a nice little video.
I'm giving clean over topics, so that's fun too.
What? Wait, what? Wait. 47? Okay, alright. That's a little too much. That's a little too much. That's a little too much. If we're doing this,
You have all of class to work on it. Alright, now I'm gonna show the video, I guess. See if I can get this video going. I wish it was a little better than it is, but it'll be fine.
Oh, okay.